Briggs-Rauscher reaction or the oscillating clock reaction, which is a cool name, though I don't, so we'll see how well it works. We tried it beforehand, and it worked like partially, so we'll see if we can get, the thing is it oscillates between 3 colors, and it'll keep doing that for like 5 minutes if it goes right.
Yeah.
So it's,
we have 3 different solutions here. The first one is potassium iodate and hydrogen sulfate. That's solution.
that's sulfuric acid.
So it is. Sulfuric acid. The second one is malonic acid, magnesium sulfate, and starch, which we'll have to shake. But and the third one is just hydrogen peroxide.
That was originally 30%, but then we diluted it.
Yes.
Okay, so we start off by mixing these two, the potassium iodate and sulfuric acid. So roughly equal amounts. I mean, the original one had you making like pretty much a liter of it, but we didn't really want to do that much. So instead, how much should we do? Like 200 mils each? But they're not exactly the same amounts.
Yeah.
200 mils.
No, do 100 because it's a 400 milliliter beaker.
I want a bigger beaker. Yep. Yeah, that would probably be a good idea.
Gonna need a bigger beaker.
That was actually right there. Good job.
You can't pause the video.
That's fine.
Okay. You guys can just cut it out. Cut, 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 cut. Keep on cutting, keep on cutting, cut, cut, cut. Cut. He grabs.
She wants to take pictures. Okay.
No, take the big one.
This is our chemistry class. 2013.
Hello. Here's a poem about chemistry. I really like chemistry. All of the atoms and the molecules and equations are very fun. The end.
It's man on the street. Krill.
I'm Becca.
Our teacher.
This is the 21st century.
Sorry. Yes, you're right. Well, I'm not an English major, right?
I don't need a gallon. Just splash a bit here.
We'll get some candidates. I gotta get one of you too, because I forgot to take it earlier. Okay, smile. Very nice.
By the way, this is a starting plate, which is totally awesome.
Yeah, that could be a demo in and of itself.
Yeah. So this basically, you put this in whatever solution you're using.
It's a magnet.
Yeah, it's a magnet. Oh, that's the wrong side.
This, and then
Yep.
you twist the dial, and it spins.
It's so simple yet so useful.
And it's coated in what, Kevlar, right?
Teflon.
Teflon. There we go.
Kevlar.
That rock thing came out. Whatever. Anyway, so it's very non-reactive. So it just stores things. Is that really?
I cleaned it.
Okay. It looks yellow in different light. Okay. Okay. So it's like 150 mils of each.
Yes, you put in equal volumes of all 3 of your solutions.
That's why we're kind of being like, how much should we put in? Because
At least
we just
roughly equal.
Yeah. And you start off with the potassium iodate and the hydrogen peroxide. If you do it the other order, it will not work. So I'm not actually sure why, but so they do with the reaction equations. And then we start to let this mix.
That's so cool.
Yeah, so the starting plate is just awesome.
I don't think we need
You want it to be a vortex, according to the reaction. Oh, and by the way, we are using our safety goggles at all times because there's iodine in this and not as concentrated anymore, but hydrogen peroxide and also some acid.
18 molar
Yeah,
sulfuric acid.
18 mole.
Yeah.
Well, I mean that we mixed it with stuff, but okay.
So first you have to let these 2 solutions mix for a little while, just so they're
Okay, so the amber
blended.
color is because of iodine ions that are produced by this first reaction. Then those iodine molecules serve as a reactant in the next reaction, so it makes this shifting reaction process. Okay, I'm gonna try to explain the thingy, but it's complicated. So what I gathered, I don't know what radical and non-radical reactions are.
Well, free radical just means you have a lone electron. That's really
Yeah, but
reactive. So I
it
don't
said
know.
something about radical and non-radical. But anyway, there's like 2 reactions going on here. We should probably add that in now. There's 2 reactions going on that both produce the iodine. One of them happens when there's a low concentration of iodine, and that one's pretty fast. Another one is when there's a large concentration of iodine, and that one's relatively slow.
Cleared up.
Yep. So what happens is when there's
Whoa.
a large... Okay, so it looks like it's working. We're just missing the blue color, so I'm guessing our starch didn't work. So...
Whoa.
It's okay, it's still cool.
Yep. So what happens is the fast reaction, when there's not much iodine, it reacts quickly. A lot of iodine is produced more than can be used in the next reaction. So that's what makes it turn amber. There's a lot of iodine. But when there's a lot of it, then the slower reaction starts taking over. So the iodine production slows down, and suddenly that's enough that it's completely consumed and more by the next reaction. So it starts clearing up because more is being consumed than is being taken, than is being produced. Yeah.
Now what's it on?
Huh?
What's the black thing?
It's a stir plate.
Stir plate. Yeah.
Okay.
Magnetic stir.
Which is just awesome. I'm assuming those bubbles are iodine.
It's working really good,
Yep.
actually.
So what's supposed to happen actually is it's supposed to turn blue after amber, because then the iodine ions and the iodine gas bind to the starch that was in there, but apparently the starch wasn't working, which we also had some issues with earlier, so, but whatever, it can
It's
just
still
turn
so
amber and
cool.
clear.
Can I keep
We had two different sets of
Wonder how long it'll
instructions, and they both
Can we just
said-
have it keep going?
It'll
Just
probably
go.
keep going for about 5 minutes.
Were the instructions contradictory?
Yeah.
Yeah.
They said, one said a lot of starch and one said almost no starch, so.
So is this the almost no starch?
Yeah.
I wonder what happens if you just dump some dry starch in there.
Do it.
Do
have
it.
some?
Do it.
Do it.
More science.
Another poem.
And what made you give
My
your
goggles
estimate
are
5 minutes?
clear,
What made you give your estimate
and
of
they
5
protect
minutes?
my eyes from
Because
hazardous
eventually the
chemicals,
reactions start to balance
Yeah.
like
out.
up there.
Drew used
Yeah,
his
it might
guessing
just be
powers.
that,
You can't just like spring this on me. I need
Just
time to
like-
think.
This is art.
It's gonna be 5
The
minutes,
bubbles
guys. I
are
can feel it in the wind.
spinning. I think the bubbles are because it's spinning.
Speed it up.
Actually, I think that's right. Well, it could be either or both.
Dob's doing work. Ross is missing. Ross sits right here.
Or 5
Moment of silence for Ross.
It was over.
It's not. You never know
So
that.
even the one that said a lot, it was still like a gram.
Or we did.
So,
We used
for what volume though?
Go for it.
Uh-oh. Excuse me.
That looks like it's getting darker.
It is good.
It is getting darker.
Uh-oh.
Oh, it's totally getting darker.
Yeah.
That looks like Coke.
Oh.
Yep.
You want to drink it?
I really recommend
We'll
that.
see if it goes back now.
Yeah.
Yeah.
Can you make it spin faster?
I mean, you don't want to make it spin so fast it sloshes out, but.
That's not even close. Make it go a little bit faster.
Faster, faster. It's just getting darker.
Yeah.
That's cool.
We could try adding the rest of
You
these.
could.
Yeah, do it.
Do it.
Do it.
Do it.
For science.
Science rules, guys.
That overflows.
It won't.
We don't have enough to make it that one. I think.
That's just gonna get dark. No,
Huh?
it'll dilute.
We're hoping to drive it the other way.
So the 18 molar
This one is.
sulfuric acid?
What?
Keep adding it.
Yeah. That's so cool. You added too much.
No.
Oh,
Wouldn't
well.
that make it darker
And the
anyways
third one?
because you're making more
What do you guys think?
iodine?
What?
Wouldn't that make it darker anyways because you're adding more iodine, not...
It's not straight
More
iodine though. There's other stuff mixed in. Like
Yeah, that's,
Iodine's
I'm not
also got
explaining the
sulfuric
exact
acid.
the exact like reactions and equations because there's a lot of random stuff in there.
If I saw that in a kitchen glass, I'd think it was Coke.
Yeah.
I would drink this.
Yeah.
Poison someone very easily.
So is this a demo for like stoichiometry or Le Chatelier or
it's
like
kind of it's oscillating reactions, which we didn't
so it's
actually
kinetics?
go
So
into
it's
this
sort of
year.
kinetics.
Yeah.
Yeah.
Yeah, but yeah, pretty
fast
much.
reactions and slow reactions.
All right. Cool.
Yep.
Are you all done?
I guess apparently it's
It
not
doesn't appear
oscillating
to be.
anymore.
Doesn't seem to be
Clearing
going
out, so.
backwards. Well, that was
That's a
awesome.
bummer.
Thank you very much.
For real?
Yeah.